When sizing a disconnect for a condensing unit, the most important factor is the maximum overcurrent protection, or MOCP, rating found on the unit's nameplate. The MOCP indicates the maximum size overcurrent protective device, such as a circuit breaker or fuses, that can be used to protect the condensing unit without violating its warranty or risking damage. In the scenario presented, the condensing unit has a nameplate with the following information: MOCP equals 40 amps, maximum circuit amperage, or MOCP, equals 23.5 amps, and it operates at 208 volts, 3-phase. The question is whether to use a 30 amp disconnect based on the maximum circuit amperage of 23.5 amps, or a 60 amp disconnect based on the maximum overcurrent protection of 40 amps. The correct choice is to use a 60 amp disconnect. Here's why. The disconnect must be sized to accommodate the maximum overcurrent protection. The maximum circuit amperage represents the maximum continuous current that the condensing unit is designed to handle safely during normal operation. The maximum overcurrent protection, on the other hand, accounts for short-term overcurrent events such as those that may occur during startup or other transient conditions. These short-term overcurrent events can exceed the maximum circuit amperage. The disconnect acts as a safety switch that allows for the complete isolation of the condensing unit from the electrical supply for maintenance or in emergency situations. It must be rated to handle the maximum overcurrent protection to ensure it can safely interrupt the circuit under fault conditions. Selecting a disconnect rated lower than the maximum overcurrent protection could result in nuisance tripping or, in a more severe scenario, failure of the disconnect to properly interrupt the circuit during an overcurrent event. Now let's delve into the specific ratings and their implications. The maximum circuit amperage of 23.5 amps indicates the continuous current a condensing unit draws under normal operating conditions. This value is used to size the conductors feeding the unit, ensuring they are adequately rated to carry the expected load. However, the maximum circuit amperage does not dictate the size of the disconnect. The maximum overcurrent protection of 40 amps specifies the maximum allowable rating of the overcurrent protection device. This value is critical for selecting the appropriate disconnect size. The disconnect must have an amperage rating equal to or greater than the maximum overcurrent protection. In this case, a 30 amp disconnect would be insufficient because it is smaller than the 40 amp maximum overcurrent protection. Therefore, a 60 amp disconnect is the correct choice because it is the next standard size above the 40 amp maximum overcurrent protection. In practical terms, the 40 amp circuit breaker in the panel protects the entire circuit, including the conductors and the condensing unit, from overcurrent conditions. The disconnect serves as a local means of isolating the condensing unit for service or maintenance. It must be capable of handling the full potential fault current that the 40 amp breaker allows. Now let's consider the wiring. While number 10 American wire gauge wire is sufficient for a 40 amp circuit and could have been used with number 12 American wire gauge wire, it's important to ensure that the wire gauge is appropriate for the specific installation conditions, including ambient temperature and conduit fill. The National Electrical Code, or NEC, provides tables and guidelines for determining the appropriate wire size based on ampacity and other factors. For example, NEC Table 310.15, formerly 310.16, provides ampacity ratings for conductors based on insulation type and temperature rating. It is essential to consult the NEC to ensure that the wiring is compliant and safe. To summarize, when sizing a disconnect for a condensing unit, the maximum overcurrent protection is the primary factor to consider. The disconnect must be rated equal to or greater than the maximum overcurrent protection to ensure proper protection against overcurrent conditions. In the case of a condensing unit with a maximum overcurrent protection of 40 amps, a 60 amp disconnect is the correct choice. Remember to consult the NEC and local electrical codes for specific requirements and guidelines related to electrical installations. This will help ensure that the installation is safe and compliant. Let's go over some related topics to ensure complete understanding of disconnect sizing and selection. Firstly, consider the different types of disconnects available. Disconnects can be fused or non-fused. Fused disconnects incorporate fuses within the disconnect enclosure to provide additional overcurrent protection at the point of disconnect. Non-fused disconnects, like the one described in the scenario, rely on the upstream overcurrent protection device such as a circuit breaker in the panel for overcurrent protection. In this case, a non-fused disconnect is being used. Secondly, think about voltage ratings. Disconnects are rated for specific voltage levels. It's crucial to select a disconnect with a voltage rating that matches or exceeds the voltage of the circuit it will be used in. In the example, the condensing unit operates at 208 volts, 3-phase. Therefore, the disconnect must be rated for at least 208 volts. Thirdly, look into short circuit current rating. The short circuit current rating, or SCCR, of a disconnect indicates the maximum short circuit current that the disconnect can safely withstand. The SCCR of the disconnect must be equal to or greater than the available fault current at the point of installation. This is a critical safety consideration to prevent equipment failure and potential hazards during short circuit events. Fourthly, think about environmental considerations. Disconnects are available in various enclosures designed for different environmental conditions. For example, disconnects may be rated for indoor use, outdoor use, or use in hazardous locations. It's important to select a disconnect with an enclosure that is appropriate for the environment in which it will be installed. For example, a disconnect installed outdoors must be rated for outdoor use and be protected from weather elements such as rain and sunlight. Fifthly, consider local codes and regulations. Electrical installations are subject to local codes and regulations. It is essential to comply with these codes and regulations when selecting and installing disconnects. Local codes may have specific requirements for disconnect sizing, location, and type. Be sure to check with the local authority having jurisdiction to ensure compliance. Sixthly, note about horsepower ratings. Some disconnects are also rated in horsepower or HP. This rating indicates the maximum horsepower of a motor that the disconnect can safely control. If the disconnect is being used to control a motor, such as the motor in the condensing unit, it's important to ensure that the disconnect has a horsepower rating that is equal to or greater than the motor's horsepower. Seventhly, consider the number of poles. Disconnects are available with different numbers of poles. The number of poles required depends on the number of conductors that need to be disconnected. In a three-phase system, a three-pole disconnect is typically required to disconnect all three-phase conductors. Eighthly, look at the enclosure type. The enclosure type of a disconnect refers to the design and construction of the enclosure that houses the disconnect components. Enclosures are classified based on their ability to protect against environmental factors such as dust, water, and corrosion. Common enclosure types include NEMA 1, NEMA 3R, NEMA 4, and NEMA 4X. Ninthly, consider accessibility. Disconnects should be installed in a location that is easily accessible for maintenance and operation. They should not be obstructed by equipment or other obstacles. The NEC specifies requirements for the accessibility of disconnects. Tenthly, think about labeling. Disconnects should be clearly labeled to indicate their purpose and the equipment they serve. This helps to prevent confusion and ensures that the correct disconnect is used for the intended equipment. The NEC also has requirements for labeling of electrical equipment, including disconnects. Now let's apply these considerations to the specific scenario of sizing a disconnect for a condensing unit. Given the maximum overcurrent protection of 40 amps, the MCA of 23.5 amps, and the 208-volt three-phase supply, the following steps should be taken. Firstly, select a non-fused disconnect rated for at least 60 amps and 208 volts. The 60 amp rating is chosen because it is the next standard size above the 40 amp maximum overcurrent protection. Secondly, verify that the disconnect has a short circuit current rating that is equal to or greater than the available fault current at the point of installation. This may require a short circuit study to determine the available fault current. Thirdly, select an enclosure type that is appropriate for the environment in which the disconnect will be installed. If the disconnect is installed outdoors, it should be rated for outdoor use. Fourthly, ensure that the wiring is properly sized and installed in accordance with the NEC and local codes. The conductors should be rated to carry at least 125% of the maximum circuit amperage, which is 23.5 amps, and should be protected by the 40 amp circuit breaker in the panel. Fifthly, install the disconnect in an accessible location and label it clearly to indicate that it serves the condensing unit. By following these steps, you can ensure that the disconnect is properly sized and installed, providing safe and reliable operation of the condensing unit. It is important to remember that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with electrical codes and safety procedures. If you are not qualified to perform electrical work, it is best to consult with a licensed electrician. In summary, when sizing a disconnect for a condensing unit, always prioritize the maximum overcurrent protection rating. This rating ensures that the disconnect can safely handle potential overcurrent events and protect the equipment from damage. Combine this with careful consideration of voltage ratings, short circuit current ratings, environmental factors, and local codes to achieve a safe and compliant electrical installation. Remember that the goal is to provide both overcurrent protection and a means of disconnecting the equipment for maintenance or emergency situations. Both aspects are equally important for ensuring the safety and reliability of the electrical system. Always consult the NEC and local electrical codes for specific requirements and guidelines related to electrical installations in your area. This will help ensure that the installation is safe and compliant with all applicable regulations. By following these guidelines and seeking the advice of qualified professionals when needed, you can ensure the safe and reliable operation of your electrical equipment.